and welcome everyone, live from the Lebanese University studio. I am Joelle Maroun.
And I am Edwin Abou Jaoude. Coming up here, the production of recycled aggregate.
After that, the mix design and the effect of the recycled aggregate on the concrete properties.
The effect of the use of recycled aggregate concrete on the environment and the SWOT analysis.
Hello everyone. The construction and demolition waste is a central component of the solid waste stream. The largest part of construction and demolition waste is concrete debris, which is 375 million tons in total. That's why it's really important to start recycling those waste and produce recycled aggregates.
For the preparation of aggregates in general, waste concrete are mechanically broken into small-sized pieces. The headquarter of a crushing plant, Gaya Deeb, will discuss with us in details these steps of production.
Thank you, Edwin, for introducing me. As mentioned, the steps of production of recycled aggregates are as follows. First of all, a hydraulic chisel breaks up concrete and masonry on site. Second, an excavator dumps the material into a crusher. Then, the crusher processes the parts into materials with a particle size of up to 60 millimeters. After that, recyclers use magnets and water flotation to remove the metal, dirt, and other materials that may bother the recycling of concrete.
Several tests and experiments were made to find the best mix design. The results obtained have shown that the ACI mix design gives the best strength for the recycled concrete aggregate.
Mixing method consists of several steps. First of all, we start by choosing the maximum size of recycled aggregate. According to three conditions that the maximum recycled aggregate should not pass. Steps of the dimension between side of forms. 1/3 of the depth of stab. 3/4 of the minimum clear spacing between individual reinforcing parts. Second step is the estimation of mixing water content. Quantity of water depends on the nominal maximum size, the particle shape, and the concrete temperature. Selection of water to cement ratio depends on several factors regarding the desired strength after 28 days. Therefore, the amount of cement is fixed by the determination made in the previous two steps. The weight of cement is equal to the weight of water divided by water to cement ratio.
The usage of recycled aggregate is essential in order to save the environment, while the main focus is to enhance the construction industry by either improving or sustaining the concrete properties. In this report, we'll discuss the effects of using recycled aggregate on concrete properties. Due to the fact that recycled aggregate is manufactured from construction waste, its usage will have a significant influence on the strength of concrete. Based on some studies, they conclude that all properties decreased when using recycled aggregate. Properties of concrete can be divided into two main sections. Fresh concrete properties as workability, and hardened concrete properties as compressive, tensile, flexural strength, durability, and modulus of elasticity. The workability of fresh concrete is a very important property, which controls various other properties of concrete, such as density and strength. The slump of concrete containing recycled aggregate is lower than that of conventional concrete. It was observed 7.5 cm of slump of concrete containing recycled aggregate, while that of the conventional concrete was 10 cm, and that is due to the higher water absorption capacity of recycled aggregate. As for the hardened properties, researchers have concluded that the use of 25 to 30% of RCA will not affect the compressive strength. The main factors that affect hardened properties is the replacement ratio of RA. When using 100% RA, we have a decrease of 20 to 25% in compressive strength, 10 to 35% in tensile strength, 0 to 30% in flexural strength, and up to 50% for the modulus of elasticity. Durability of concrete is defined as the ability of concrete to withstand chemical attacks and physical actions. The incorporation of RCA in concrete increases permeability properties such as water absorption and chloride migration. This will result in poorer durability than that of NA-based concrete. Is this the end of recycled aggregate after showing the decrease in all of concrete properties? Surely not. Many improvement techniques are used to regain properties of conventional concrete. We have improvement in mixing like increasing the amount of water, pre-saturation of recycled aggregate in water, increasing cement content in the concrete composition, or the addition of mineral that will improve concrete properties like fly ash, blast furnace slag, silica fume.
Recycling the waste during the construction has a lot of advantages. Let's discuss its effect on the environment in this report. The incorporation of recycled aggregates in concrete not only reduces the extraction of natural resources, but also decreases landfill disposal of construction and demolition waste. Hence, environmental impacts and costs are reduced, promoting the use of recycled aggregates and circular economy. In particular, gravel mining is known to be harmful to the environment, and dumping excess sand is considered unsuitable for landfills. The mining of recycled aggregates can and will reduce this environmental damage.
Like everything, recycled aggregate present disadvantages and advantages. In this video, we will also discuss those positive and negative sides by using the SWOT analysis method.
Recycled concrete aggregates present many strengths. The use of recycled aggregates is eco-friendly. In fact, using recycled aggregates preserves natural resources and reduces the amount of carbon dioxide released due to the crushing process. It's an excellent cost-effective alternative because its use can save money and reduce transportation costs. Moreover, recycled aggregates can be used for a wide range of applications. Recycled aggregates also present certain weaknesses. Using high-concentrated recycled aggregates may lead to cracks and faults within the structure. Recycled aggregates reduce the strength, workability and durability of concrete and increase its water absorption, drying, shrinkage and creep. Despite those weaknesses, recycled aggregates present various opportunities like conserving landfill space, saving time and creating employment opportunities in the recycling industry. Finally, the threats of recycled aggregates are the aesthetic issues, the lack of rules and regulations, and the lack of specifications and guidelines.
As already said, using construction and demolition waste as an aggregate for the new concrete has an immense potential and can reduce the use of natural aggregates and the problem of mining them. Let's hope that this improvement spreads all over the world. Thank you for watching.
And wait for new ideas.